So from scratch, our networking is started, and first we'll discuss what is a difference between network and networking. First, we'll discuss here what is the difference between network and networking. First, the network is a connection of multiple devices which is connected via any medium like cable, like optical cables. We have a medium physical layer. In physical layer, we'll discuss anyway the connection between the network is a connection of multiple devices which is connected via any medium, that is cable or Wi-Fi. So any media, it will be applicated to say physical media. So what is networking? So here networking is a which is uses to devices and equipments. The process of sending data from one end to another end is called a networking. Does it mean devices? We have a network devices like routers, switches, and any equipments. It bases the sending data from one end to another end. So here, just now we discussed here, we have a different branches at different locations. So with the help of here L3 device, router consists of L3 device and switch. So the connection between the devices, it will be happen. It's ISP. The connection between together at two different locations like here we have a local area network and a wide area network. What does it mean? Before this, it'll clear about here. What is LAN and WAN? So, local area network. So, in your organization, if it is a small size organization or medium size of organization, if you have a different location, different branches. So, LAN consists of it will be building any single building, and it will be having the multiple users or multiple different departments. So it means it's a switch L2 device, access switch, and it's a core device. So it's a core device, it's an access switch, and access switches are connected to core switches, core devices, those are the routers, and these all are the at only single location at in a single building or at in one campus network, you can assume. This campus network wants to communicate a different location campus network. So it will be connected with the help of WAN. So if here mostly we'll use is private IP ranges, and here we'll use anyway we'll discuss what is private IP, what is public IP. So here we'll use it LAN location, it single geographical location. We'll use mostly private ranges, IP addresses are private IP addresses. And if you want to communicate it to two different locations, we have a public IP address. With the help of wide area network only it is possible. If you have any queries, ask me. So here is a theory. So LAN is a local area network, and WAN is a wide area network. So where we'll use mostly at enterprise computer network, separate in two general types of technologies. Here we have a two at enterprise network will use LAN and WAN. So interconnection of devices, it will use the LAN and WAN. LAN set devices connection with the same location. It will be office, building, campus, or same building, campus building. So WAN set of LAN connected each other in different geographical location. Together, LAN and WAN create a complete enterprise computer network. So working together to do the job of computer network, delivering data from one device to another device. So delivering data, not only devices, delivering the data at one location to another location. So this is the basic network fundamentals. So if you have any questions, ask me. I will start the OSI model. Actually, OSA is a reference model, and OSA were developed by the IOS, International Organization for Standardization, and introduced at 1980s. And it is a layer architecture consists of 7 layers, which define and explain how to communicate happens in between two or more network devices within the organizations. So how will communicate? It will be explained each and every layer having their own work roles. So each layer defined of a set of function in data communication. So here we have mainly 7 layers. Those are the first one is application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So application layer and presentation layer and session layer, these 3 layers, not for the network engineers. In this layer, whichever the software engineers, you can assume they'll work on these layers. So we'll work up to layer 4. So transport layer, network layer, and data link layer and physical layer. So I'll explain each and every one. Each and every layer, what is the roles and responsibility. Actually at application layer, so in this application layer, so the data, the whichever the we are using the applications, so it is responsible for providing our internet interface for user to interact with application services or network services. It will be, so whenever you can assume like you have connected one network here. So this is the example will explain to each and every. Actually, this is the network architecture. Network architecture. So this is the core device, and those core devices connected to core devices, and core device is connected to distribution layer device. Distribution layer device. And distribution layer devices are connected to access device. So these are the switches, and these are also switches. You can assume this is a router. You can assume this is a core switches, multi-layer switches are we are using here. And in this access layer switches are connected like this. So the end user is available here. The end user. This is the entire LAN network, local area network. This is the end users, PCs. These are all are the PCs connected to access switches. In real time, whenever you'll see the network to architecture is likewise. So in access layer, we'll create the layer 2 protocols. Up to here layer 2 protocols will work, and here layer 3 protocols will work. Anyway, so whichever the application he is using, those are the work at application layer. So we who is using? End user. So end user, whichever the applications are he's using, web browser, it will be work here. For example, he's using a Facebook, FB. So it will be moved to here. And anyway, the application layer work at end user. So application layer is responsible for providing interface for the users to interact with application services and network services, whichever. So how will identify? Now hold on this port numbers. Anyway, with the help of port number, will identify the service. Which service this end user is using? Which service? Here we are having the port number of telnet, SSH, NTP, SMTP, DNS, DHCP, RIP, HTTP, and HTTP. This is a port numbers 23, 22. So every service having their own port number. With the help of port number, will identify the service. We will identify the service which application end user is using with the help of port number. So we have a total port numbers here 2 to the power of 16. The value comes 65535. The range it will be. In this, we have a reserved port numbers and unreserved port number. These are the unreserved port numbers. So it will be randomly, it will be take when we'll discuss later on sessions, but it is a reserved port numbers means these all are the reserved port number. Every service will reserve one port number in this range only 121023. With the help of port number, will identify the service which application end user is using. Clear?
Yes, it is clear.
Fine. Now move to the presentation layer. Yeah. The presentation layer here, mostly with the help of presentation layer, the data will be encoding and decoding and encryption and decryption and comprehension and decomprehension. So what does that mean? Presentation layer is responsible for the defining a standard format for the data. So which standard format? That is a text format or graphic format. It will be JPG, GIF, TIFF format, whichever the format, it will be verified with the encoding and decoding. So here, whenever the sender, whenever the user is using any application, it will be moved from scratch to bottom to top, and it will be give the reply top to bottom. So anyway, see here, the encoding, when it will be the data is sending, that time it will be encoding, and whenever the receiver receiving the information again from receiving the information is sending and receiving that application means he's requesting some information and he's getting the acknowledgement. So whenever he's sending information, that time it will be encoded that, and whenever the he is receiving, that time it will be decoded. So same thing here, encryption and decryption will be happen. Encryption means whichever we are using the passwords, whichever the data will be, whenever you are using password acknowledging, so that time receiving decryption means it will be move star one two, this kind of format, this kind of format it will move the data. And receiving time it will be acknowledged that. Encryption and decryption, encrypted over entire data, it will be encrypted.
So encrypted means
So
which what will show? Here it is showing sending like numbers, right? Encrypt.
the encryption form you can assume likewise only. Yeah, yes. Whichever we are
Decrypt.
sending the data, that format will be totally, it will be changed. So
Okay.
if you are sending hi myself Alim, if I am sending hi myself Alim, this format anyone can read. If I am sending the same way star one two one star hash that star something a, likewise in this data no one can read. That is encryption and decryption. Whenever the sender sending, that is encrypted form, and once the receiver receiving, so who's and all sending and receiving the information, that will be encrypt and decrypt, it will be happen
Okay.
at the
Got it.
presentation layer. So format of data, which predictor, stacker, whichever the we are using the applications, you can assume likewise. So these actually mainly a presentation and application and session layers. These three layers, the responsibility is to whichever we are using the applications. So it will be changing the format, it will be creating the sessions, which application we are using. So based on the application, the port number will identify which application we are using. So if you are using these are the network protocols like Telnet and SSH, and these are the all are the network protocols only. And in this, these are the web browsing protocols. Both are the web browsing protocols, and this is a routing protocol. Whichever we are using application layer protocols, it will be identify the service. So here those protocol will be encryption and decryption, encoding and decoding, and comprehension and decomprehension. Entire thing will be happen in this layer, and one more is the session layer. So nothing, it will be session layer. It will be creating the session, maintaining the session, and initiate the session. And once the session will be closed, it will be delete that session. The conversation is done, then it will be delete the session. So session layer is the responsible for the creating, maintaining, and deleting the session. Initiating and maintaining and deleting the session and stop the session. Once the conversation is done, it will be stop the session. Means he's got the acknowledgement. Once he sent the traffic and he got the acknowledgement, the session will be closed. That is the closing the session. Now move to the transport layer. The transport layer is the heart of the layer. Network. Layer 4 is a transport layer. So transport layer, we can identify the service of application layer at this layer with the help of port number. So first, what it will be do, a transport layer, whichever service is coming from top layer, that is application layer. First, it will be identify the service. First, it will be identify the service. Which service is coming? So based on that, it will be sent to end user. So it will be multiplexing and demultiplexing, same thing. And segmentations and sequencing and reassembling and error correction and flow control. The major function described at this transport layer are, first it will be identify the service, which service is coming. So based on that, so for example, again, I'm taking here, I'll use like HTTP traffic, HTTP traffic, any HTTPS you can assume, like that is we are using here Facebook. So first he hit the traffic Facebook application. So first it will be identify which service is coming, which service is initiated the host user. So if HTTP, then the port number it will be add, that is 443. So after then it will be multiplexing and demultiplexing, means the whichever the traffic is, it will be moved to the like segments. Likewise, it will be added segments like I'm using here some Facebook traffic. It means I have sent the text message to someone. Hi, what you are doing? Something. What you are doing. So I have sent one message. So first it will be multiplexing, means in order wise it will be, it will first it will become what, and it will second it will packet will be segment. These all are the segments. In network layer it will be work on the segments. So this is a packet is like 5. So this is the 4, packet is 4, and this one is the 3. And once the traffic, likewise it will be moved, whichever the port number we see. Actually, how we are communicating, with some, this is a Facebook server, FB server, at different location. You sit at a different location, you initiated some traffic, so you have connected multiple ISPs, so it will pass on likewise. So here you are using multiple connections in between. These all are the ether channel under comes under. So it will be move likewise. Whichever the packet free of that, it will be load balancing something. So based on that, packets will be multiplexing and emails multiplexing. After then it will be reach likewise. Then it will be once it will be received here, it started from here only multiplexing. Hi, what you are doing? Actual proper sentence is likewise. But once he's receiving likewise, so that is it will be do the demultiplexing. So Facebook server will be do demultiplexing once it will be received, and whichever the proper segment sequencing and reassembling. Hi, what you are doing? So likewise, it will be sequencing and reassembling whichever the error correction are there. Error are also is available. So it will be correct the entire information. So flow control, how the flow is coming, it will be control flow also. So entire process will be happen in this transport layer. So that is the reason I mentioned it. This is the heart of the layer. First, it will be identify the service, which traffic is coming. So after then, it will be which format is coming, text format or which format. It based on that, it will be work. And whichever the sequencing is proper or not. So entire process will be assembling and reassembling whichever the segment. These are the segments you can assume. So based on the segment at net a transport layer, what will be happen? The data will be segmented. So in network layer, layer 4, the packets we call it as a packet. So in L2, we call it as a frames. And in L1, we call it as a bits. Anyway, we'll discuss. So here segment. So now move to the network layer. So at network layer, the main responsibility it represent for end-to-end transformation of data across multiple networks. So it is a responsible for end-to-end transmission of data across multiple networks. So basically, whenever we are using here we'll use mainly routers. The devices here will use the routers. So at one LAN location to another location. So the data will be passed on it with the help of ISP. Whenever we are using the ISP, so it will be passed on the multiple networks. So here you can assume like multiple ISPs. So every ISP will use definitely they'll own routings, then they are using their own routing protocols here, and definitely will use the routing protocols. We are also use the routing protocols. So routing protocols work based on the two different networks. So router will work R1 device. Router will work at two different networks. So I will discuss the devices also. Before that, so at network layer, it will be work on logical addressing and path determination. So path determination means if we have multiple path, so based on the which way is the shortest path, it will be elected and it will pass the information. If I want to communicate to different branches, so which path is the shortest path, it will be elect. So here in network layer, mostly two protocols will work. Those are the routed and routing protocols. So here we have two protocols in network layer. It's an important thing. This is an important concept. Please follow. So routed protocol act as data carries and define logical addressing. And routing protocols perform the path determination. It will be select the best path. Just I have mentioned here, if we have the multiple path from one location to another location, so it will be elect based on the shortest path. In between are, this is a path 1 and this is a path 2. So here we having the two ISPs only, so it will be considered as a, it will be best path. It will be elected, this is the path, and traffic will be sent through via this network. So basically network layer will work across multiple networks. So here this is a different network, 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 this is a different network. And here we are using like logical addressing and path determination are described at this layer. The protocol work here, network layer are routed protocols and routing protocols. So routing protocol, routed protocol example are IP addressing, IP v4 version 4 and IP version 6. Apart from that, earlier we'll use IPX, IPLDoc. These are nowadays we are not using. Nowadays we are using the technology that is only IP. This is the layer 2 technology, the AppleTalk and IPX. Now leave it. Anyways, it's the old legacy technologies. And now move to the routing protocol examples are RIP, IGRP, and EAGRP, and OSPF. Apart from that, ISIS also it is there, etc. And in network devices, here we'll use routers and multi-layer switches. So it means at network layer, it will be mostly work in between the networks, two different networks. If I want to communicate two different networks, so mostly which device will use routers. If I want to communicate within a network, if I want to communicate at single local area network, so this is my LAN network, and is LAN having multiple branches, multiple departments. So this is a LAN having the multiple devices, multiple branches. So here mostly at LAN locations, which devices will use switches. So switch work only single network within a network. Single will work, switch will work within a network. Now move to the router will work multiple networks. If I want to communicate to two different locations, then we need a routers. Now move to the any doubts in network layer?
No, Ali.
Great. Now move to the data link layer. So it is responsible for the end-to-end delivery of the data between the devices on LAN network. See, so whenever we discussing WAN, that time layer 3 we required. Whenever we are discussing, so only LAN local area network. So there will use mostly switches. Those are the switches only. At a single network, it will be work LAN location. End-to-end delivery of data between the devices on local area network segment. Data link layer comprises of two sublayers. See here, MAC address and LLC. So what is MAC? Media Access Control. MAC stands for Media Access Control. It deals with hardware addresses. So every device. So whenever you are using switch or router or PC or mobile or whichever the device, that device definitely having their own physical IP address. MAC stands for MAC, we'll call it as a physical IP address also. Physical address, not physical IP, physical address. So MAC address are 12-digit hexadecimal identifier used to identify the devices uniquely on the network segment. So actually 12-digit hexadecimal means, so it's actually 48-bit information. 48-bit information. In that 48-bit information, it will be 16 actually we call it as a 16 byte. So 16 byte, 1 byte, it is a actually
I think it's
is not
6
4.
bytes, right, Alim?
16 plus 16, 32. 32 plus 16,
Yeah, it's
how much?
48, but 6 bytes equals to 48 bits. It's not like that.
Pardon?
Like, I think it's 6 bytes is equals to 48 bits. So,
Wait,
so
16 plus 16 plus 16 actually 48, and this 6 byte, it will be 4 digit. So that is the reason, that is 4 digit of hexadecimal digit, 4 digit, and it's a 4 digit. It means AA, AA, likewise, BB, BB, likewise, CC, CC. So this is a format of MAC address. This is a format of MAC address, and it will be 48 bits. The information is 48 bits of information. In this 4 digit, and 4 digit is likewise. It also provide error correction and cyclic redundancy check and framing also. So here I have explained. So the whichever the data is sending, that will be moved to the switches. Like it will be in switches. What it will be happen? Frames the information whichever that they are sending the switches. It will be like it's a information that is we call it as a frame. And here we call it as a packet. At network layer, we call it as a packet. And so the MAC address format is likewise. So MAC address, media, MAC stands for Media Access Control. It is a physical address, and size of the MAC address is 48 bits. Those we explain, and MAC address will be globally unique. It's a globally unique, and every device having the unique MAC address. The MAC address called as physical address also. We call it as a physical address also. And every device, laptop, PC, and hardware MAC addresses, mobile also, even the mobile also having the unique MAC address. Every Cisco device is also having the MAC addresses. So MAC address is represented in 12 hexadecimal, that is only. And MAC address is provided by IEEE standard. IEEE, they provided to us MAC address. And the format is likewise. The MAC address format is likewise. It's a broadcast address basically. This is a, you can assume like this is a MAC address likewise will get, but MAC address, whenever you see FFFF, it's a broadcasting address. So I'll explain the what is broadcast also. Each port on switch device has own MAC address as well as individual MAC address. And in switches, having each port having one MAC address. And each port in router device has its own MAC address, but the router does not have its own individual MAC address. So in between switch and router, so switch having its own MAC address as well as individual. So switch devices has its own MAC address as well as individual MAC address can be there for switch devices. So in between switch and router, switch having the multiple interfaces. If we have switch having the multiple interfaces, every interface having the one MAC address and switch also having one MAC address. But in router case, the router, how many ports router device has its own MAC address. Router, how many ports having the entire ports, the router having MAC address, but router doesn't have their own MAC address. Because switch is a L2 device. So switch need a own MAC address as well as ports also having MAC addresses. Don't confuse it here. Switch having its own MAC address as well as switch how many ports having. So this port having own MAC address and this port having own MAC address, this port having more MAC address. Minimum switches having 24 ports or 48 ports. So every port having own MAC address as well as this switch also having their own MAC address. But in router case, if we have a limited ports in router 4 or 5, that is based on a model, but switches routers having the limited ports and switches having the multiple ports. Those are the 24 ports switch having and 48 ports we have. But at router case, they routers having the limited ports and each port having their own MAC address, but router doesn't have own MAC address because it's a layer 3 device. And the PCs also having the MAC address. Their own MAC address, PCs also having, that is physical IP address. We call it as a physical IP address. Laptop, PCs, every device. And what about the LLC? Logical link control. It deals with layer 3, network layer. Devices work at data link layer, switches, and these are working devices. But here two protocols work. One is MAC and one is the LLC. In this LLC, it deals with the layer 3 information. So if I want to communicate, so see, this is a switch and this is a router. In between, whichever way are using the information, those are the work here LLC. LLC. So those are the like ARP protocol, ARP, and ICMP, how they are working in between ARP means ARP with the help of ARP will find out the with the knowing MAC address with the help of knowing MAC address a something will find out the unknown IP address with the help of ARP only it is possible. Those will work here. Which protocol? Those are the LLC. It will be clear in TCP IP model. So this is the anyway we'll discuss the ARP ICMP. But in this layer, you can assume like it is a 2.5 layer. It will work. And this is a mainly L2 protocol. This is a 2.5. So this actually work in layer 2 only. So as we discussed in starting only, OSI model was the reference model. So human being understanding purpose, we have a OSI model. Actually, it's a reference model. So we have a one more protocol, TCP IP model. It's an implementation model. So here only 4 layers are there. These are the application layer, and this is the transport host to host, and this is a network and data comes, and it's a network access layer, and this is a physical layer only. So we have a only here in TCP IP model. This is the first one, and this is the second one, and this is a third one, and this is a fourth one. 4 layers only. So when we discuss TCP IP, that time you will get the what is LLC. LLC. That is why I mentioned 2.5 protocol and ARP. ARP will work at 2.5. In between the data link and transport layer. Sorry, network layer and data link layer. Fine. And it will be data link layer with the help of LLC. It will be deals and it will be communicate with the help of LLC only. Link, logical link control. Now we'll discuss physical layer. Now we'll move to the TCP IP. So physical layer is a layer 1. So it deals with physical transmission of binary data on the given media. Which media? Those with the copper media, fiber media, wireless media. It comes under physical. So it also deals with electrical, mechanical, and functional specifications of devices and media. So mainly the connection between two devices, whichever the connection we are using in between, physical connection, the wire connection, that is a copper wire, fiber wire, or wireless also. If you are using the wireless device also, you can assume this is an end user. This is a router of Wi-Fi router. Will connect with the help of Wi-Fi signals, radio signals. This is also media only. So physical media. So it will be comes under electrical, mechanical, functional, any media type of media. It will be how it will be format will be like bits format. In this electrical signal or any format, how the data will be transferred 0 1 0 1 0. So basically this is the one of network device, and this network devices will understand 0 1 0 1 only. If you are sending high, it won't accept this routers won't understand this kind of language. Human can understand English language, any language, English or Telugu, whichever language human can understand, but routers will understand only mechanical machine learning language only, mechanical language or electrical. So this is the way it will be understand. Machine language only, the machines will understand. The bits, the format is here bits. So that is what encoding and decoding. So this is the encoding only and decoding also 0 1 0 1. Once the sender send, this is the format it will be, and once the receiver receive, that will be decode the format. Whichever the proper format is the text format we sent hi, but the format is gone like by 0 1 0 1. So that is the reason it will be encoding and decoding also. Who? The media. And here we are having the copper media, fiber media, wireless media. The mode of transmission is signals. And which devices will use here? Hub and modems and repeaters. Transmission media. Hub is not an intelligent device basically. It is like extension box. Okay. I'll give some brief about the devices also. Any doubts? Till. So we have a network devices. Hub. First we'll move to the hub. Hub is used to connect two or more network devices to make communication possible with the same network addresses. Same network where we'll use hubs or within a network we'll use. And hub is a dumb device. It is not an intelligent device. Hub does not have a topology information. Doesn't have any topology information. Like whenever if it will again it will broadcast the information. So I'll explain what is broadcast, what is unicast, what is multicast. So here we have a network types. So the data will be format like broadcast, unicast, and multicast. So I'm taking here one switch and here I'm taking one router. So first, what is unicast? So unicast is one-to-one transmission of information. In network communication, one-to-one transmission. One-to-one. Who will we do? The routers will be communicate one-to-one only. And what is multicast? Multicast. The multicast
One
is
to many
one-to
users.
group. Yeah, one-to-one group. One to many, one to one group or one to many. So now coming to the broadcast switches, it will be broadcast the information, whichever the information they got, one to all, that is broadcast. So at hub, what they will do, broadcast the information, whichever the information they got, they broadcast. See, if you have in your home one extension box, in that extension box, you have the multiple ports. So every port, if you can broadcast the information, it will be used likewise. So best example is hub, the extension box. They are getting the electrical and they'll transmit that only. The port of hub devices work half duplex mode of communication. So here we have two types of communication, half and full duplex. So half duplex means only sender sending and receiver receiving. So it is a not simultaneously, it will be send and receive the information. Only one way communication it will be half. But at full duplex, the simultaneously the data will be sent and received at a time. That is full duplex. Half duplex and full duplex. Two-way communication happen in networking. So hubs are half duplex devices. Hub has one single collision domain. So collision domain means sending and receiving. That time receiver and sending at a time, it will be collision. It will be collision at it. It is a single collision domain mainly. Sender sending and receiver also receiving at a time. Then that is collision. So switches having single collision, that is the reason it's a half duplex devices. If we have multiple collision domains means, so we can send also and we can receive also, yeah, different ways. So how works on physical layer, say layer 1. So as we discussed, layer 1 device is hub. Now move to the switch.
Excuse me, sorry to interrupt. Can you please explain what's half duplex and full duplex?
Fine, okay, fine.
Yeah, thank you.
So as I mentioned, one is half duplex and second one is full duplex. So here the hub having only half duplex. So at a time, only in a one time, the connection likewise. So now coming to the half duplex, it will be send the information only one direction. And this switch, this end user is initiated some packets. He initiated some traffic. So the switches both are it single LAN set. These are the LAN local area networks. So that is the reason I have taken the switches. So here the sender is sending some traffic and receiver is receiving the tag. Receiver PC1 is sending one packet and PC2 is receiving that packet. So that time only, if he's giving the reply, the traffic is passing here, so it won't accept. So which traffic it is won't accept? Whenever he's giving the reply, it won't accept because entire traffic is not received by this user. Once he will receive the entire traffic, then only he can send the information. Again, that time he won't receive. Only one-way communication is happening here. Only one-way communication, either sending, either receiving. Not two-way communication, not simultaneously. It is not sending at a time and receiving at a time. Either it will be send the information, either it will be receive the information. If it is sending means it won't receive the information. That this user won't receive the information. That is, we call it as a half duplex. If full duplex means it will be send at a time, it will be received at a time simultaneously. Both it will be sent and it will be received at a time, at a single time. Got it?
Yeah, got it. Thank you.
Great. Now, so we'll discuss about switch. So switch is used to connect two or more network devices to make communication possible with same network, and switch also will work at same network only, not at a different location, different networks. Switch also will work same network only. Means it will be work at LAN location only, you can assume. It will be work at LAN local area network only. So this is a local area network. If you are using here one router, L3 device. So it will be different network and this one is a different network. Both are in the different networks in this case. So switch will work at up to here only. It's how many users are you can connect, it will be work. It basically switch work based on the MAC address. It will be not work based on the IP address, because that is the reason switch is a L2 device, layer 2 device. At layer 2 what we have? MAC address only, media access control only, MAC address only. Even though we have LLC, logical link connections. So logical link connections, again we have a ARP. So these also will work to communicate, make the possibility of one device to another device with the help of L3. So it will be L3, make the possibility. So now coming to the MAC address. So MAC address, it's L2. So that is the reason switch also will work the L2 only, and switch what it will be do, broadcast the information. And switch, it is an intelligent device, but the hub is it's not it's a dumb device, not intelligent device. So because that is the reason switches has topology information. It means switch having topology information means. So this is a PC1 and PC1, PC2, PC3, PC4. How many PCs are connected up to the switch having? If 24 port switch, we can connect to 24 species. So how many PCs are connected this switch? The switch knows entire PC information. Entire PC information. How? The physical address. With the help of physical address, MAC address, it knows entire topology information. Entire topology information switches, they knows, they have the entire topology information. So that is the reason they maintain which table? MAC table and CAM table. Both are same. Content addressable memory and media access control. And so switches maintain physical table. Physical table means MAC address table. So that is the reason they have entire topology information. If they are connected 24 pieces, PC1, PC2, PC3, PC4, up to 24 pieces, they know, switches knows entire PC information. So switch send the data there behalf of CAM table, behalf of whichever, if I want to communicate PC1 to PC2. So here we have two PCs. You can assume PC1 and we have connected with the help of switch two PCs. This is a PC1 and PC2. Now packet flow, I'm explaining here how they communicate. Switch 1 is a switch, and so at lay, this is a PC means which PC having their own knowing MAC address. That is by default, every PC having their own MAC address. We can take as some A. Likewise, we'll take four. And this PC having BB. If I want to communicate from PC A1 to PC2, so with the help of MAC address, it will be possible or not? So we need a here, whenever if I want to communicate from L2 to L2, so with MAC addresses, it won't possible. So once the information will move, so it will be MAC address verified. then it will move to the LLC, logical link control. LLC, logical link control. So it will pass on that. So we need a IP addressing here. So that is the reason I have to take one IP address. So here also one condition is there, whichever you are taking the network, so same network you should have to take 1.1. So here just I am changing the only host bit here. So these are the network bit, and this one also network bit, and this one also network bit. Here I have taken the class C IP address. So 3 network bits, one is the host bit. So that is the reason I have changed only one bit, that is last bit. This is a bit and this one is a bit. So this is we should have to give. It's the same network I have given. So PC1 wants to communicate PC2. So again, here one protocol will work, that is ARP. With the help of ARP, so we know the IP addresses here. We know the IP addresses. Knowing IP address 2 will find out the unknown MAC address. So how the packet flow it will happen? So PC1, this is a source, and PC2, this is a destination. This is a source and this is a destination. Which PC? PC1 and PC2. I have initiated some traffic that is high. I'm sending this high information. So before that, whenever the sending the high information, whichever you are using the application, first it will be move which layer? Physical media. So it will be convert like 0, 1, 0, 1. 0, 1 something, and it will be give the bit information, it will be give to the layer 2. At layer 2, what will be happen? The source MAC address, it will be happen. So source MAC address is A likewise. So I am taking 2 A's only. And what about my layer 3 information? BB. So BB, it don't know. So for switch, what it will be do? If how many ports are connected for this switch, it will broadcast the information to every PC. It will broadcast the information. So it will be broadcast the information to broadcast for him also. So broadcast means one to all. Switch, what it will be do? Broadcast the information. So you can, and switches have one broadcast domain by default, but only for the very first packet. After that, it will be send all the packets are unicast. So first it will be broadcast the information when he don't know the MAC address. If he know the MAC address, it will be he will be communicate unicastly. So that is the reason, find out purpose, he is doing broadcast. Switch is doing the broadcast. Got it? When if he don't know the MAC address where the traffic is transferred, he don't know. That is the reason he don't know the MAC address also. So that is the reason we know the IP address. So manually we are configuring. So that is the reason we know the IP address. With the behalf of the IP address, we are sending to traffic him, but this PC don't know, because this time PC don't have topology information. This topology information. So switch, what it will do? Broadcast the information. That is F. So 12 Fs. After then, once it will be give to the, this is the L2 information. Now move to the L3. It will be give pass on to L3. PC1 and PC2. So source IP address here and destination IP address. What is source IP address? We know our source IP address is 1.1. And what about my destination IP address? 1.2. So we reached with the help of L3, our packet is reached here. Now our packet is reached. Now what with half of the L3 information, L3 layer, we reached to our destination. Now this PC is giving now reply to him for PC1. Now coming to the, again it's L3, and this is now coming to the PC2 top, and PC1 is here what one. So before that, at layer 3 we have two protocols, right? TCP and DP. So TCP is a reliable protocol and UDP is an unreliable protocol. Behalf of the TCP, it is giving the acknowledgement. You can assume like TCP likewise. So now move to the, it is now PC to source IP addresses and what 1.2. Now whenever he is giving the reply, the time source IP address is his IP address and destination IP address is DST. Destination IP address is 1.1 when he's giving the reply that time, sending the reply that time. So now PC, this switch now got the which table? MAC table. So whenever he's getting the information that time, whichever he's sending, getting the information that time, it will be get his MAC address also, L2 information also. So it will be store CAM table or MAC table, and it will be give to PC to, that is MAC address now. Giving now source MAC address is BB, and PC already know, switch knows AA MAC table. So this is a packet flow actually. So I am explaining. So not much more here. Don't worry about that. We know the knowing MAC address to unknown MAC address. We are finding with the help of address resolution protocol ARP. So here we know the IP address, both IP addresses. So we don't know the MAC addresses. That time it will be broadcast the information. So with the help of broadcasting FF. So first packet is FF. The switch don't know, that is the reason it will broadcast the information. So after then it is giving the reply, that time giving reply time after then L2 and giving reply time, it will be giving to source, giving reply to switch. That time the switch stores the MAC information of PCs, whichever PCs it will store the information. So that is the reason switch is a intelligent device. And switch having per port collision domain. So it will be sent and it will be received at a time. So it will be worked on full duplex mode. It will be switches having the full duplex, hub only having the half duplex. And switch will work at data link layer. Data link layer, switches will work. And after then we have a router. Again, router, it's a intelligent device. And a router will work between two networks. Guys, have you got it? The packet flow? If you are
Yes,
not
sir.
get means if you are not get means I'll explain again those packet flow. So router, it is a device which is used to make communication possible between two different networks. Router will work. That is the reason it network layer device, that is L3. Devices with, it will be work different network addresses. Two different networks, devices with different networks. And a router device maintain routing table. Actually, router will maintain routing table and ARP table also, address resolution protocol. ARP table also. ARP means again MAC table. With the help of show ARP, we can find out the ARP table. Router will maintain two tables, routing table as well as ARP table. And switch maintain only MAC table, that is CAM table, CAM or MAC table. And but switch maintain routing table. In this routing table, we have the best path from source to destination. And ports of router device work on full duplex mode only. The router having the full duplex at a time simultaneously, they'll send and receive the information. Router has per port broadcast domain. Router has per port collision domain, and maximum number of ports at router having, as I mentioned, the router limited ports, but switches having 24 ports and 48 ports, but routers having maximum 8 ports. Router not having the multiple ports. Routers, what they will do, routings only. So router works on network layer. It will be communicate at two different geographical locations. You can assume simply, if we have a different locations, so this is a different location and this one is a different location, so we'll use mostly here routers only in between. It will be work between two branches, between two networks, between two organizations. Router will work. And these are about the router. And we have not only the routers, not only switches, we have the firewalls also. Firewall are the network devices only. Again, for security purpose, will monitor the traffic, will filter the traffic, will deny or permit the traffic. Those are the firewalls also. Those are the physical devices also we have. And apart from that, applications also, we have applications also, or combination of both also. We have firewall applications also, as well as we have the physical device also. Those are the network devices also only. Now move to the devices we discussed here. Anything? Overview, quick overview. See, what is networking, network, difference between network and networking, and what is LAN and what is WAN, and OSI model. OSI, it's a reference model, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. And what about the port numbers we discussed here? And network architecture, core and distribution access layer. These are network architecture in every organization. Likewise only it will be happen. First, it's connected to access switches, switches to distribution switches, and distribution switches to core switches. In between, access switches will create mainly VLANs here. Will create VLAN, because we have to communicate different. This is a one branch, one department, account department, AC department. This is the HR department, and this one is the sales department. So every department having their own VLAN. So and every VLAN their own access switch. Access switches again connected to the distribution switch, and distribution switch to will use here routing protocols. Routing also, as well as ACLs also will create. If which traffic we have to deny, which traffic we have to permit. Those things will be ACL and routings will configure in this between. So anyway, I will discuss more about it. Network architecture also. This is a brief about the network architecture. Apart from that, presentation layer and session layer, we discussed the entire thing. And here, transport layer. In this transport layer, two protocols work. TCP. One more is UDP. And TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. And TCP is a reliable protocol, and UDP it's a unreliable protocol, because TCP will use three-way handshake. TCP, why it is a reliable protocol means the user is sending some information. So PC1 and PC2. PC1 is sending some information. PC2, it will be give the acknowledgement. So that is the reason it will be used three-way handshake, and it is reliable protocol. So whenever is sending sync packet, it will be give sync plus ACK. sync plus syncing plus acknowledgement, ACK, and it will be give the acknowledgement. This is a three-way handshake. And where it will be possible? In layer 4, in transport layer, and TCP uses protocol number is 6, and UDP uses protocol number is 17. Again, what is protocol number? The protocol number also will identify the service, which service we are using. TCP service, that is 6, and if UDP service, that is 17. And TCP having their own, you can assume like HTTP traffic. These are all are the traffics only. Whichever we are using the protocol traffic, those comes under TCP or UDP basis traffic only. Any doubts in TCP UDP? Yes. In this TCP or UDP concept, if you have any questions.
Nothing from my end.
No, Alim.
Fine. And this is all about the OSI model. And apart from that OSI model, we have a TCP IP model. In this TCP IP model, actually 4 layers only. So we call it as a TCP transmission control protocol, internet protocol model. It is a earlier that OSI model is a reference model, and open system interconnection, that is a reference model, and this one is the implementation model. And who invited it? DOD, Department of Defense. We call it as one more also, defense model also, DOD model also. And it was developed by ARPANET. So American Research Project Agency, and they developed it and invited DOD. They developed it, and it was developed in 1970 and adopted as a protocol standard ARPANET. In 1983 they adapted, and it is a practical model, means whichever we are using in real time, the devices, switches, routers, it will be practically this model only we are implementing. After the implementation of the protocol model was defined publicly, once they defined the publicly, it is came at 1983. There have 4 layers only here. So application layer, transport or host to host layer, and network or internet layer, and network access layer. So application means user information, and here we'll use TCP IP, again transmission control protocol and user datagram protocol, and here we'll use ARP, address resolution protocol, and here we having the bits of information. So some more about the So this is the internet layer protocol. So in internet is a layer 2, L2, or it can L3 plus L3 also. In which layer? At OSI model, it's called OSI model. It's L2 and L3 information. There we have the IP addresses and ICMP, Internet Control Message Protocol, and ARP, Address Resolution Protocol, and reverse ARP. And what is internet protocol? Provide connection, best effects, delivery, routing at datagrams, and IP is not concerned with the connect of datagrams. It look for way to move datagrams at their destinations. So we have a router in between. So two different locations are two different. This is a one LAN. You can assume this is a one LAN network and this one is a different LAN network. So data delivery from one network to other network. How it will be happen? The entire thing will be efforts here only. So if we have router, if you have in between multiple paths. So if this one is a router and one more router here have this LAN is at different location. This is the one LAN. This one is the LAN and this one is connected to this router and one more router also in between. It will be elected the best path. Which routing protocols will be elected the best path? How the data will be forwarded? So with the help of IP addressing, it will be possible. So it will be select the best routing protocols also here. And ICMP, what is ICMP? ICMP, it's Internet Control Message Protocol. Message are carry in IP datagram and used to send an error control messages. So whenever you are ping with the help of ping command, you try to ping from 1.1 PC to 1.2. So behind the ping, one more protocol is work, that is ICMP, Internet Control Message Protocol. It will be send the request and it will be get the reply. So sending request and giving the acknowledgement. So entire process will be done with the help of ICMP only. The following are some common events and messages that ICMP related to destination unreachable, or see, this is the ping, this is a way. So it will be reach or not. If any error is happen in between when we pinging with the help of ping protocol. So sorry, ping with the help of pinging packet internet gopher. Ping stands for packet internet gopher. Will check the connectivity in between devices, in between network devices. It's a trace through. It's a troubleshooting command, ping and trace route. So the behind the ping, which protocol will work? ICMP. So ICMP having two messages. One is request, one is acknowledgement. So request, echo request, and sorry, not request and acknowledgement. Echo request and echo reply, not reply. Echo request packet, whenever the sending the information, it will be send the empty packet, and whenever it will be receive the packets, the 10 bit size is 8. The bit size is 0, and as echo request bit size is 0 and echo reply bit size is 8. ICMP. So whenever you are initiating the ping command, so behind the ping command, ICMP will work. In that ICMP, two messages will be happen. One is echo request, one is echo reply. Echo request, the bit size is 0 and echo reply, the bit size is 8. So with the help of request command, you are requesting some information, and reply command, you are getting the reply. So this is all about ping and trace route. If you have the multiple devices like router 1 and router 2, router 3, some packets are dropping here only. Whenever you initiated ping, so not working, then trace route. So the trace route, with the help of trace route, how many devices are available, how many up to which devices, up to how many devices our network is flow happen. After then, the trace route will be star, 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 likewise. Packets are not reachable. It will be shown with the help of trace route command. I'll show you in labs, but with the help of trace route, how many devices are available, that many devices will check with the help of trace route command. And our protocol, with the help of our knowing IP address to, sorry, knowing MAC address to, we will find out unknown, sorry, knowing IP address to unknown MAC address will find out, will resolve the, it uses to resolve MAC address with the help of knowing IP address. The knowing IP address to will resolve the MAC address, and reverse ARP. This is also we knowing. So this also work internet layer only. It works exactly opposite to ARP. Opposite to ARP means ARP is knowing a IP address to unknown MAC address we are find out. But here unknown IP address to unknown IP address to knowing MAC address will find out. Though it resolve IP address with the help of knowing MAC address. So in this case, we know the IP address. In this case, we know the MAC address. So reverse only. So where it will be work, basically reverse are at DHCP protocol. In this DHCP, it will be work. When we discuss DHCP, that time we'll discuss mostly in at DHCP only it will be work in this DHCP protocol. So that is the reason, as I mentioned, this in L3, it's all about L3. Apart from that, L2 plus L3. In which protocol? This is TCP IP protocol. They combined like this. L2 and L3. And now move to the network access layer, means it's a physical layer again. Bits of information it will be happen. This is all about today. We discussed TCP IP model and network devices and OSI model. If you have any queries, I'll stop the recording. If you have any queries, ask me.